.NET Aspire is an opinionated, cloud-ready stack for building observable, production-ready, and distributed applications. Frankly, I'm a little bit tired of the buzzword bingo. It can be quite tricky to understand exactly what .NET Aspire is all about, and how that can benefit you as a developer. My name is Philip Ekberg, and let's take a look at .NET Aspire. In reality, .NET Aspire is simply a set of tools that are built to help us more easily build applications. We might have lots of different microservices, a distributed cache, databases, and other types of dependencies in our applications. Managing all of this can be a little bit tricky. This is where .NET Aspire will make it easy for us. Let's jump over to Visual Studio and create a completely new solution to understand exactly what .NET Aspire is going to do for us. Using .NET Aspire starts with either adding this to an existing project or setting up a starter application. Let's do that. I'll target the latest version of .NET. We can choose to add a cache, which will enable output caching. This will make some decisions as to what it adds to the application. We're going to add this later in the video, so make sure that you stick around for that. Once we've created a .NET Aspire starter application, we're going to get a set of different projects in our solution. Don't worry though, if you're not creating a completely new project, which probably most of us aren't, you can still add .NET Aspire to your existing application. I do hope that at the end of this video, you'll understand exactly what the different pieces are that are necessary to get .NET Aspire added to an existing application. There's now 4 different projects in our solution. Let's go through each of them to understand exactly what role they play in terms of .NET Aspire. We have an API service project, which is just our normal API that probably powers the application. In this case, this is a minimal API. Again, this is just an example API that's backing the application that we are building. Essentially, it's just a microservice that will expose functionality to an application such as a web application. And speaking of a web application, there's in fact a web application added as a project as well. This is using Blazor, but that doesn't really matter. What matters here is that the web application is going to somehow consume the API. Normally, a solution consists of one or more backing APIs, even one or more frontends. And then, if we'd like to debug this, what you'd normally do is to set the web project and the API projects as the starter projects, then press F5 and hope that everything just works. However, if someone were to use a different port when debugging this locally, the web application will immediately run into issues trying to communicate with the API. This means spending time on unnecessary work to get that to work. All right, for now, just think of the API and the web application as what you'd replace with your applications. .NET Aspire introduces 2 new separate projects that will make a few decisions to help us connect the API with the web project. It will introduce opinions in terms of logging, telemetry, service discovery, and a few other things as well. This is where the service default projects make an entrance. .NET Aspire uses this to introduce the default decisions as how we'd like to configure the different applications. For example, it configures OpenTelemetry, sets a couple of add default health checks, adds service discovery, configures some HTTP client defaults, and some other opinionated decisions as well. Do you remember the buzzword opinionated? This is just that. Decisions made for us to make our development faster and easier. Let's not spend too much time in the service defaults project. You can drill into this on your own to understand exactly what types of decisions are made here, and then what's added to the different applications. Both the API project as well as the web project will now use this to enable the service defaults for that project, so that both of them will work similarly. The final project that's introduced is known as the app host. This is where the magic happens. Although, we all know that there's no such thing as magic in computer science, as we're the developers building the actual magic. Really, this is just where it's all connected together. The app host is a web application. It will be in charge of connecting those different dependencies together. It controls starting and stopping those services, and provides us with a dashboard to work with all of this. If we look at the program.cs, this is where it references the API as well as the web application. We can see that the web frontend is exposing some external HTTP endpoints. It has a reference to the API service, and it also indicates that it needs to wait for the API service to start before it attempts starting the web frontend. All this may seem a little bit odd at a first glance, but as we run the application, hopefully it becomes a little bit more clear. When I run the app host project, what's going to happen is that it's going to start a dashboard, which then lists all our different projects. We can see the API project, and we can see the web project. .NET Aspire is in charge of starting the different applications, and also connecting them together. If our web application would like to consume something from the API, .NET Aspire will ensure that it populates the web application with the correct references to the API service. This works because we set it up so that the web project references the API service. The dashboard will simply show us all the different applications that we've added to our app host. We can point to as many microservices or projects running MVC or minimal APIs or Blazor as we'd like. We can connect them all together and get .NET Aspire to inject configuration into the different projects. Both the web frontend and the API service are now both running. If I click the endpoint URL for the web frontend, as you'd expect, this works just fine. .NET Aspire has started the web project without us having to select multiple startup projects. And if we had any breakpoint set, this would of course work as well. Even though all that we're running is the app host. We can load the weather, and all of the application just works as you would expect. It wouldn't have mattered if this was an MVC project, or as in this case, Blazor. .NET Aspire would have started this through the app host no matter what. Think of the app host as being in charge of running the applications. If we go back to the dashboard, we can inspect the console output for the different applications. In fact, we can see the console output for the API service and the web frontend, both separately so that we can understand exactly what's happening in those applications. Just like if you were running them separately as multiple startup projects. The dashboard also shows us structured logs, traces, and metrics. All of this will make it easier for us to build our applications locally. Don't worry though, there's a story for how we get this deployed as well. But let's get back to that a little bit later on. If we like to, we could have added as many microservices or web frontends as we'd want. We could then connect them together and make it easier for them to discover each other. But how does the web project know where to reach the API? It simply uses the name of the API service. And how does that actually work? The HTTP client will be smart enough to know that it's supposed to look for a configuration with a particular name. It will use HTTP or HTTPS if that's configured, because this can be a little bit different depending on how you're executing the application. Jumping over to the dashboard, we can check the configuration that has been set by .NET Aspire. The web frontend has a setting, which points to that API service. It populates this based on the information from the app host, the IP and the port which it runs the application on. Super clever, isn't it? Not feeling overwhelmed with excitement? Let's make it a little bit more interesting. This is just an API and a web frontend. Real-world applications has a lot more to it. Why not extend the application with a couple of things? I'd like to make it possible for the API to consume a Redis cache, a distributed cache, that is. To do this, and make it easier on myself, I'd like to run Redis in Docker. I can set this up using .NET Aspire. In fact, .NET Aspire can interact with any type of container, making this an extremely flexible tool. We need to add a couple of different packages and install them into the application for .NET Aspire to know that it's working with Redis. We could have taken a more generic route and install Redis as a simple Docker container, but there's a specific tool created for .NET Aspire to make it aware of Redis. This will provide some extra functionality as we begin to build our application. Because .NET Aspire provides a lot of tooling, it also provides great extensibility. We can use community-contributed additions to .NET Aspire, and of course, there's also components managed by Microsoft. For example, we have something called aspire.hosting.redis, which I'm going to install into the application. Once I've done this, I can tell my app host that I require a Redis cache. Doing so is very simple. This adds Redis to the application. I'd like this to live outside of the scope of my application, meaning the configured lifetime would be persistent. And why is that? Because spawning a Docker container each time I press F5 may add a little bit of latency to debugging, which is quite unnecessary. Even though the Redis container itself is super quick to start, other types of containers might not be. This is going to run in Docker, meaning that you will need Docker installed on your machine. I'm going to add Redis Insight as well, which is a way for us to later explore the data stored in Redis. Finally, I'm going to add a reference to Redis for both the API as well as the web project. I'm going to tell them both to wait for the cache to have started. We could now use a Redis cache as an output cache or as a distributed cache in either of the applications quite easily. If we start the application, it's going to pull down that Docker image, configure the Redis container, and start it up. And then the different projects in the application can consume the cache. The appropriate connection strings will be populated into those different applications that depend on that container. How do we then use this in one of our applications? Let's see how we do this in the API project. I'll install another package so that we can use an distributed cache. Once that package is installed, we can instruct the builder that we'd like to add a Redis distributed cache with a specific connection name. This will then go ahead and grab that connection information that the app host injected into the application. We can now use an distributed cache, which is managed by Redis, and start it from the .NET Aspire app host. Amazing, isn't it? I'll map a new endpoint called samples, which will get the distributed cache injected into it. This will be connecting to the Redis cache. We can try and find a key in the cache. If it's available, not null, and there's more than 0 characters, then we're going to go ahead and return that. Otherwise, we're going to set that to some arbitrary value, potentially something that's expensive to retrieve. We'll store this and return the value back to the caller. Starting the app host, we can see that it pulls down that Redis container, it starts it, and if I list all my Docker containers on my machine, I can see that this is running. We can also see that in the .NET Aspire dashboard. Here we can see the container, and we could even restart that if we'd like to. Navigating to the API and running that samples endpoint a couple of times, we can see that we get the same information. This means that the data was properly stored in the cache. Notice what happens if I go ahead and kill the Docker container. We can do that from the dashboard, and then try to invoke that endpoint again. This won't work, as the iDistributed cache relies on that cache to be available. This is a little bit of a problem, and something that you'd have to handle. With .NET 9, there's a concept called hybrid cache. It's a preview feature in .NET 9, so we have to manually enable this as well. This will use a distributed cache if it's available, and also use a second store, which will be a memory cache, to store it locally inside the application. While outside of the scope of using .NET Aspire, I think this is a great opportunity to also look at the hybrid cache. I'm going to add microsoft.extensions.caching.hybrid to the application. Once this has been added, we can add the hybrid cache. The hybrid cache instance will then use the iDistributed cache if it's available. We're going to get an error now, but don't worry, it's because this is an experimental package. Let's just ignore the error for now. I'll then add a new endpoint called samples hybrid. I'll inject the hybrid cache, and using this is frankly a lot easier in comparison to using the iDistributed cache. I've restarted the app host, and I'm going to navigate to the samples hybrid endpoint, and the data is returned successfully. If we were to kill the container and run the endpoint again, would you assume that this would work? Of course it will. Otherwise, this demo would have been pointless. Because the data is available in the local memory cache, this would work properly. You could optionally configure different lifetimes for the distributed and the memory cache. If we were to then start the Redis container again, it will then use the distributed cache once the memory cache has been invalidated. Do you remember the Redis insights that I talked a little bit about earlier? We can go ahead and navigate to this as well, to see all the data available in the Redis cache. This makes local development a whole lot easier. Having the capability is really good for debugging and understanding exactly what goes into the cache, and potentially what doesn't. We extended the application with a cache. We also made that discoverable in our .NET Aspire dashboard. We then looked at the data available in the cache, ensuring that the data is populated in the cache appropriately. What if we have a lot of existing projects and microservices, web projects, and we don't really want to start from scratch? Well, as you've seen now, there's not really a lot to a .NET Aspire project. You'd have to add the app host, which can be added to any solution, and then add a service defaults project. Ensure that you use the service defaults in the different projects. In the app host, you'd point to those different services, web frontends, caches, and any arbitrary container that you rely on. Then, when you press F5, all of that will be started automatically. Configuration will be populated into those different services. The whole idea with .NET Aspire is to make it easier to develop our applications. I've added this to projects that I've worked on for a long time that didn't use any .NET Aspire from the start. And frankly, it has made my life a bit easier. One of the headaches and the questions that I get asked quite a lot is what happens once we're done with our local development. We'd like to publish the application. There's a lot of dependencies and there's a lot of configurations necessary. Is there a publishing story for .NET Aspire? Could you right-click and deploy in Visual Studio, which you probably shouldn't? There is actually a publishing story. We can do it manually. All joking aside, while that's a good idea, as you'd have total control of how you're spending your money on different resources, I'd like to make it a little bit easier on myself and automate this as much as possible. As everything is already set up in .NET Aspire, wouldn't it be great if there was a way to automate this, to simply say that we'd like to create everything that has been set up and configured the same way as it has been in our application? This is possible using the Azure Developer CLI. To install this, we'll use PowerShell. We can easily use winget to install Microsoft AZD. When that's installed, using the terminal, navigate to the app host project folder. Now run azd init to initialize the automatic publishing of an application. Don't worry, so far this won't actually publish anything anywhere, because we haven't authenticated with Azure yet. So you're safe. What this is doing is scanning the application for code and for projects that will work with the Azure CLI. It will find the .NET Aspire project, and as it identifies the project, it will know exactly what to do with it. It identifies the different projects and the dependencies, which is then used to set up the deployment strategy. It will ask us to configure an environment name, which will be used in Azure when setting up all the resources. Once that's been done, it will generate an azure.yaml and a nextsteps.md. The markdown file talks about the next steps necessary to get this published to the cloud. We can read through this to get information about how to do that. Of course, the end goal from Microsoft's point of view is for everyone to use Azure. Great, running this was successful. It's going to tell us that our application is now ready for the cloud. But what does that actually entail? How do we get this to the cloud? We now have to run azd up to send our application up to the cloud. The cloud's not actually up though, but send it off to the cloud. For that to work, we first have to log in to the Azure Developer CLI. Now, when I run azd up, it's going to ask me which subscription to use and where to publish this. I'm going to create mine in Sweden because that's closest to me and my customers. This will take a little while, and after it completes, there will be a lot of new resources created in Azure. This is where you need to be a little bit careful, as it could potentially get quite expensive. Always double-check the settings of what's been automatically created. After this video, I should probably remember to remove the resources that I've been using for these demo purposes. I actually forgot to do that once when working with Cosmos DB, and that ended up being quite expensive. We can see the publishing took a little while, but nevertheless, it succeeded. It created the cache, the API service, it set up the web frontend, as well as the .NET Aspire dashboard. Before you get really scared of running the .NET Aspire dashboard in the cloud, let me set something straight. It's not actually public. It won't allow anyone in the world to stop your services, terminate containers, and discovering the different pieces of your system, or even worse, look at the traces and metrics. This actually requires authentication. You have to log into your Microsoft account to access the dashboard. Then you can see the different configurations for the different projects. If we run the web application, we can see that everything works, even though this is now running in Azure. We didn't have to do a whole lot for this to actually work. If we jump over to Azure and take a look at what's been added, there's a couple of different container applications and other Azure resources to make this work. Inspecting the web application and its configuration, we can see that it's referencing the API, but this time it points to where it's created in Azure. And again, all of this was automatic because .NET Aspire knows all about our different projects. The Azure Developer CLI was able to figure out how these work together and where the dependencies are. Once we publish this to Azure, it connects it all together. This makes the development experience a lot better. We could now get the same insight we had locally, in the cloud. It certainly makes my life a lot easier, as I have the exact same experience now that it's been published to Azure. Be it traces, metrics, logs, health checks, starting and stopping, all of that functionality is now available here as well. It published everything except Redis Insights, but I'm quite happy with that. I could connect to my Redis cache and check the data in other ways rather than having Insights published as a separate container. Finally, there's one thing that I like to touch on, and that's the extensibility of working with the dashboard. Let's say that I'd like to add the capability to my API service to clear some data, and only do that through the .NET Aspire dashboard. I can very easily introduce custom functionality and custom commands. I can create one of these custom commands. It could then ask for some dependencies, which would allow us to run some actions. For example, clearing a cache, a database, or a similar functionality. The command then returns a result based on what happened. I can now associate this with one of my references used in the app host. This will then show up in the .NET Aspire dashboard, meaning that I can create some really great functionality that will help us further speed up the development process. To wrap this up, .NET Aspire provides a lot of tooling to allow us to connect different pieces of our applications together, making it easier to set up references between the different services, injecting information between those different applications, making it easier for us to spin up Docker containers as a part of our local development experience, and even having that later then transitioned to the cloud. I honestly think that if I get onto a client project and they're using .NET Aspire, which immediately lets me press F5 without having to worry about setting up hundreds of different things locally, that's a huge success and will make my life a lot easier. And essentially, be a lot cheaper for them as well when they bring on new people to the project. Circling back to the buzzword bingo that we talked about earlier, .NET Aspire is an opinionated, cloud-ready stack for building observable, production-ready, and distributed applications. Hopefully now, this buzzword bingo makes a lot more sense. Even though I'm hesitant to use all of those buzzwords, it explains exactly what .NET Aspire is all about. It is opinionated in terms of how it has its opinions in the service defaults, in the way it's structured, and the different dependencies that it uses. For example, open telemetry. It's cloud-ready, as you can immediately publish the application and its different projects to the cloud. It's relying on containerized applications to make it even easier and better. Depending on the overall architecture that we are using to build our applications, this may also mean that the application is scalable and distributed. Following the path set forward by the startup project, this definitely promotes some good architectural decisions on building distributed applications. Hopefully, you're excited to take a look at .NET Aspire. Try to apply this to an existing project or experiment with the starter project. There's a lot to further explore, but I will let you play around with that yourself. Please let me know in the comments if this is going to be something that you'd like to take a look at. I hope you enjoyed this video. If you did, leave a like and subscribe to the channel. My name is Philip Ekberg, and I'll see you in the next video.